you should know first of all what it means by a beat. Okay. When we talk about a beat is a beat occur or beating occur when two sounds waves of different equally near different frequencies approach your ear. Now there is a difference in loudness. Sometimes you hear loud noise, sometimes you hear a loud voice and the low voice, and that difference is caused by beat or beating. Okay, so this is your ear, and now there is one wave approaching your ear, and there is another wave approaching your ear. So there is, you know about interference. There is interference, which we define as constructive interference and the destructive interference. Now this I've got it. These are some of nearly equal frequencies. For example, I say F1 is 340 Hz and the F2 is, let's say, 336 Hz. Okay, so there is a difference between one frequency and the other frequency. Okay, so let's say this is 340. Okay, and this is 336. Now the difference is called the beat. That is F of the beat is, now here is seen is clearly seen, it is 4. But this beat frequency can be obtained as the difference can be 336 minus 340 or 340 minus 336. So that's why we take absolute value of F1 minus F2. That means whether we get positive or negative, we consider our answer to be positive, the absolute value. So let's say we have, let me take a duster, which is happen to be the gown of man. So suppose we have two turning forks. These are two turning forks. This frequency is equal to, frequency 1 is 340, and now has, okay, and now we have another turning fork, which is, they are supposed to be sounded together, like this one. Then F2 is not known, but we already know that suppose F of the beat is 4 Hz, and now we are being asked to obtain F2, so we just say that F of the beat is equal to F1 minus F2 into absolute value. So this can be like F of the beat is equal to, now this can be like F1 is 340 Hz, now minus F2. So this is 4 Hz. F of the beat is given as 4 Hz. So to obtain 4 Hz, either F2 can be, F2 is equal to 336 Hz, that's the number which is subtracted with 340 to get 4 Hz. Or F2 can be 344 Hz. So this will be the value of F2. F2 can be 344 Hz, or F2 can be 336 Hz. That which can give you the frequency, the beat frequency of 4. So F2 can be higher or can be lower than F1. Okay. Knowing that, now let us ask ourselves, suppose F2, first the beat frequency was 4 Hz. Now suppose F2 is loaded. Suppose F2 is loaded. Suppose F2 is loaded. So let's say with wax. So by loading F2, which means its frequency will become low. Now after loading, suppose the beat frequency, F of the beat become 60 Hz. Okay, the difference become more bigger, 60 Hz. Now suppose we are being asked what was F2. What was F2? Remember that F2 was equal to 336 and F2 was equal to 344 as we still remember. So what was F2? Now if you understand the question, now we can move on and say the beat frequency for the second case is given as absolute value of F1 minus F2 So F1, again, the beat frequency is now 6 Hertz. Okay, so this now is equal to 340 Hertz minus F2. So if that's the case, now we can say, for us to obtain F2, can you get F2? No, you're not there. So for us to obtain F2, we have to do what? We have to get F2, we have to, either by guessing or if we open this one, F2 can be now 346 Hertz, or F2 can be 334 Hertz. So for this case here, we have to say that F2, the second turning fork was loaded, so its frequency was lowered. But remember that the first, before that, F2 before loading was equal to 336 Hertz. Okay, and the F2 before loading was equal to 344 Hertz. Now after loading, here is before, here is after. After loading, F2 is equal to 334 Hertz. Okay, or F2 has become 346 Hertz. So we expected that the frequency of F2 could lower. And here, if the frequency of F2 is 346, only by judging, we can see that this is higher. Okay, this is more than it before. But if F2 is 336 after loading, then this has been lowered. So we shall take this one, 336 Hertz to be our first frequency, because it has been lowered by loading the wax. So that is BT frequency. If you want to know about destructive, construction, and the difference in constructive they just happen. For example, if we say destructive, first of all, did you understand this one? I think yes. Destructive takes place when the two waves are in phase. They are moving in opposite direction and they are in phase. That means the crest of one wave is all the same with the crest of the other wave. For example, this is wave 1 and this is another wave. No, these two waves are in phase. When they combine, when you join these two waves, you get another bigger wave. Now this is what we call constructive interference. Constructive interference. And destructive interference is when two waves are out of phase. Two waves are out of phase. They are moving in the same direction, and they are moving in the opposite direction. They are out of phase. When you combine these two waves, they decrease. Okay, they decrease. For example, this is positive 2, and this is negative 3. But this is positive 2, and this is positive 3. So they add up to get positive 5. And this one, they add up to get negative 1. So this is what we call destructive interference, and this is what we call constructive interference. So constructive interference is when two waves which are moving in the opposite direction, by saying they are in the same direction, moving in the opposite direction or the same direction, but when the two waves combine and alter, when two waves combine and they subtract each other, then we say this here destructive interference, this here constructive interference. But for more of this, for more of this one, I will come later and explain it more. Thank you very much. Thank you very much.